Good morning. In this experiment, we are going to explain about one-way and two-way slab analysis by using Staad Pro. So I think you already have the idea how the load will be distributing here, one-way and two-way slab. So depending on Ly and Lx ratio. So we'll go for the new project. I'll choose a space, plane or floor also. Again, choosing the floor because the slab is the floor element. File name is one-way and two-way slab. And the length units will be default meter and force units will be kilonewton. Going for the next, so we'll choose the add beam here and we'll make it finish because we are going to draw the structure. So snap node beam, in that one right one you can see the edit option. We are choosing the plane XZ direction. So I'm going to design here with the two plates which are one-way slab and two-way slab near together. So clicking on XZ, so in the horizontal direction which one we are mentioning X direction, and the vertical it will be Z direction. So here you can see that one, below that one construction lines. So here in the X direction we are mentioning 14, in the Z direction we are mentioning 4 to draw the structure clearly. The spacing will be 1 meter 1 meter. Click OK. So 0 to 5 meters and 14. And again coming back to 4, we are drawing exactly as two boxes, two rectangular boxes here. When we want to move to another place, we have to make it control press. So after finishing of that one, you close the snap node beam where you display the dimension. So that we can calculate depending on Ly and Lx ratio. Is it possible to define one-way and two-way slab? So first step is geometry snap node beam. By using that one we are drawing here. So 5 by 4 it will be less than 2, so it will be called as a two-way slab, and 9 by 4 it will be more than 2, so it will be called as a one-way slab. The next one will go for the property, same define rectangle 0.35 0.45, clicking on the add and closing of that one. So property, general property, define rectangle. For all the beams we can use this rectangle property because slab is going to present it between the beam element. So assign to view, assign S. So you can check on the 3D rendering how the beams is created, but the experiment is one-way and two-way slab. So first we had to draw the slab surface. Either we can go for the surface meshing kind of thing, or we can draw the add plate also, add plate quad geometry in that one. So it actually called as add 4 red plates also. So because it is going to connect the 4 nodes here, you can see that one. The plate is drawn clearly, the surface very clear, but with given any thickness up to now. So we are checking that one 3D rendering of the right box also, as you can see here. So now we'll give the thickness, plate thickness. So this one is a plate element thickness. I'm giving 0.25, that is my 250 mm slab thickness minimum. So plate thickness giving assign to view, assign S. So now you can see that one supports. The property we given plate thickness also. Next we'll go for the third step here. That is nothing but supports, create, and adding the support, create, fixed, add. This one assign to view. So we kept the completely fixed support below the foundation. We are assigning to directly to the slab element. It will give a small warning. We'll discuss it later. So next one is the loadings, load case details, loading type. We'll get the dead load sulfate. Live load will be the floor load. That is nothing but one-way and two-way is the floor element. So we have to distribute the load according to one-way or two-way. So giving the cases, first one dead load. Second one will be the live load. So in the dead load, I'm giving the sulfate. As we already discussed, sulfate will be the common to all the steps, all the experiments also. Sulfate assigned to view, assign S. So live load, add. That one floor load we had to give. So we select that one box aside. We'll keep it aside because we have to give the ranges between the X, Y, Z directions. So we will take the node cursor now. With the help of node cursor, we can give that one. Taking the node cursor. So pressure, we are giving approximately -4. So first one is the two-way slab. 5/4 is a two-way slab. So first one X minimum, Y minimum, Z minimum. So there is no Y range. So X, Z we have to make it. So X is minimum 0, Z is minimum 0. X increased maximum 5 value at the end of that room only. So now it will come to the Z maximum. So Z maximum we can see there 4 value. So it's a two-way slab, so there is no need to tick on the one-way distribution. So we'll add it and close it. So you can see the two-way distribution load is adding, how much it is going on. Next we'll go for the floor load. Again, get the load distribution to one-way slab now. So -4. So X range, so it is going to start with the minimum value 5 now. The maximum, you can see the 14. So X minimum is 5. The maximum will be, we are taking it as a 14 now, as you can see there. Minimum representation, now Z minimum 0, maximum it will be 4. So for everything that we have to check all the rooms, you can see that one 9/4 it will be more than 2. So we will call it as the one-way slab. So we are taking on the one-way distribution. So we'll go for the add, close it. So you can see the two-way and one-way load distribution, how the load distributed went it there. We'll go for the next one, analysis, no print, add and close it. We'll go for the next one, design. It's a concrete structure obviously. So we finished the fifth step also, analysis and print. Last one, design, run concrete, and the current code IS 456. So Indian standard 456. So previously we were using BS 800 also. So define parameters, FCK value 20,000. AFI main 415,000. Compressive strength of the concrete and yield strength of the steel. It will be common step for all the concrete structures design. So next you will go for the commands. These are the design parameters, FCK and AFI main. We are giving FI main only for the main reinforcement. For distribution shear reinforcement, automatically it will take adapted. So FC FI main we are giving assigned to view now. Next we'll go for the commands, design beam. So design slab element because column is not existing there. We'll go for the takeoff. We'll choose the design beam now here. Get to assign to view because total structure beams are representing there. And also slab also there. So design element also assigned to view. So we'll go for the analyze. You can see there we are giving all the commands here now. So in the commands we are giving design beam and design slab element only because columns existing is not there. So analyze and analysis. You can see that two warnings are there. Sorry, one warning is there. That is nothing but all degree of freedom is fixed there. So because Y means and the condition of that one, given that one, the below of the slab element directly given the supports. That one is a mistake. But as per the experiment, we insisted to design only slab element. If we kept the columns, it will be called as a 2D frame. So that's why given directly support to the slab element below that one. So as you can see here, this is the beam reinforcement designing. And below of this one, we can see the element design summary, nothing but slab element design of summary. And below of that one, this one is a takeoff. So here you can see that one, 2 plates. The plate number 8 and 9, nothing but slab number. So longitudinal reinforcement and transverse reinforcement. That is nothing but in the short direction and longer direction, we'll keep that much area here. So this one is a beam reinforcement cross section diagram.